Alright, so this is the infamous problem that I was telling you of why I taught you the quote-unquote wrong way, if you will, but why I taught you as far as how to identify a relative max or a relative min. I said a relative max or min occur when there are sign changes on the first derivative and that specific derivative at that set C was equal to 0. This derivative does not have to equal to 0 to be a relative max or min. So let's say that I have this function here. This is a relative max, this is a relative min, this is a relative min. But if I have this function where it's a cusp, then it goes down. This is a relative min, this is a relative min, and this is a relative max. The reason of it being is that all you really need is sign changes. And you see the derivative goes from positive to negative here. Sign change to curve, there it is. Okay? It does not have to equal 0 as far as a derivative for it to be a relative max or min. It just has to be defined as a point. It has to be continuous. The reason why I taught you that it had to equal 0 is because most of the questions that you will get revolve around it equaling 0. Okay? And if it's undefined, it's still going to exist as a point, just it's an undefined slope. In this sense, a cusp. So 95% of the problems that you will get are where the derivative is equal to 0. Those critical numbers you find, you solve it, you set equal to 0. That's why I taught it to you that way. However, the true interpretation is the sign changes, and only the sign changes. Almost like you would do the second derivative, sign changes with points of inflection. Alright, so let f be a function defined and continuous on the closed interval a to b. So whatever the function is, we say here's a, here's b. C is somewhere in between a and b. Okay? So somewhere in between a and b is where C lies. Okay? And which of the following statements must be true? Well, f prime of C exists. We just showed that f prime of C does not have to exist per this cusp for it to be a max or min. Okay, so it's not 1. If f prime of C exists, then it is 0. Okay, so if f prime of C exists, which right here it doesn't, here it does, it has to equal 0. So if it is differentiable, that means I can take the derivative, it must be 0. This is why I showed it the way I taught it throughout the semester, because this is the big one that is the application to all the real world problems. Okay, so 2 does check out. If f double prime of C exists, then it is negative or equal to 0. So by looking at this, it is going to be negative or equal to 0. In this case, it's going to be negative because this shows the concave down, this shows the slope is 0. This is a relative max. If you look back into your notes, this revolves around the fact of second derivative test. It's concave down, and it's also the slope is 0. So the only thing that I want to make sure that you know is that f prime of C doesn't have to exist for there to exist a relative max or relative min. So which ones must be true? The answer is E, 2 and 3.